Alright, overclocking is the idea of taking a processor's nominal rated value and exceeding it. It's not advised by any means as far as the manufacturer is concerned. It increases heat, increases instability, and increases many other factors in your system in general.
And void your
But-
warranty.
Not if you don't have burn marks.
It does not void your warranty if you use overclocking on the motherboard.
On the BIOS side, not
yeah, the
software
BIOS side, not on the software side, right?
However, let's say you have a 3 gigahertz processor rated, and you can overclock it to 3.4 gigahertz. Without getting into too much detail, this affects all the other speeds and latencies inside your system, but it's the idea of taking your processor speed and bumping it up. It increases speed more in the long run. But the idea is it hugely increases the heat. And the idea we're trying to accomplish is we're taking out another factor, and that's the layer of this metal between the top of the processor and your heatsink. Now you say you just use some really good heatsink compound. Now that'll work, or use water cooling. If you don't go with water cooling, there's the
Tell us what you're
it's expensive for no reason.
Water and electricity, what could possibly go wrong?
You can have non-conductive liquid or use
Oh, it loses that over
100%
time.
distilled water, but regardless. The problem I'm trying to accomplish, the solution I'm trying to accomplish here is underneath that top layer of zinc, that silver shiny surface, there's copper. A thin layer of copper before the die. We don't want to get to the die. There goes the process. However, if I take a rough sketch of the top of the processor, let's say
I can see
for,
that.
even though this isn't completely correct, for practicality purposes, this is a quad-core processor. Each corner is taking a core of the processor. Can you see, is that colors up there too?
Turn it off.
Yeah, go ahead.
I'm going to use red as heat. In a standard system, you would see something like this. With a normal processor, normal heatsink, you would see something like the heat being really hot on these outside corners. And then being mildly cool somewhere towards the center. And the reason for this is because right in the center is usually where the manufacturer puts most of that zinc coating. This is usually the highest point of the processor. So when your heatsink is touching the top, it's usually touching right in the middle. This is good for decent heat, decent cooling. But the outsides are usually iffy. And if you're overclocking, you're increasing the heat regardless. So now that what was all right to get away with before now is greatly increasing your chances of damaging that processor due to heat. So what we want to do is obviously we want to cool out this entire thing. Well, what's the best way to do that? Shave off that top layer. Or don't overclock. That works too. But if you're like me, you'll buy a really cheap processor and make it one of the better ones.
But you a game or 2 hours?
I do my share of gaming, yes.
All the you come from.
Oh yeah, I don't disagree with that one bit. However, does everybody kind of understand what I was trying to get with that, first off?
Yes.
So what we want to do with my half-gray sketch is make that top layer of that processor as smooth and as flat as possible. I've even seen some of these that are so flat that it virtually creates a suction cup between the top of the processor and the bottom of the heatsink. It's so flat that nothing between them, it just suction. In that case, you don't even need a heat sink compound. I don't recommend it, but you don't need it. So how you do this, how you normally would do this, is you have a really flat surface. I'm having, the only thing I can find is the top of this plastic box. Now what I recommend is a piece of glass, 4" by 4" piece of glass. Probably one of the flattest things you'll find. You can buy it at a hardware store for $5.
This is high comedy.
Continue.
Generally use 4 grits of sandpaper, starting at 400 to start shaving everything off, 800 to start smoothing out, 1000 and 2000 to eventually get to that ultramarine finish. This, when you guys saw this was finished at 800, not even 2000. So this will end up being this will look like you could see your reflection if I used 2000 grit and took my time on it.
That's automotive sandpaper right there.
I'm using automotive sandpaper.
All right.
About $10 a pack.
Yeah, it ain't cheap.
But it's wet dry sanding too. 3M. You can buy that in all the grits you need. But like I said, 400, 800, 1000, and then 2000. That's the usual steps you go.
What do you do with the glass?
The glass is your flat surface, because we are trying to make this flat, right? So if I just kind of hold in my hand here and just start taking away,
Yeah, that's all.
you never know if you're going to get it flat or not. So what you do is you kind of, where can I do this? Everybody will see it. Can everybody kind of see this point right here? Maybe here? You'll take your glass or your flat surface on your bottom, have your sandpaper flat on top of it. I have a glove, but I don't even care about this thing anymore. This did work. Hold it by the sides. Usually you go by 3 points. Middle of one side, opposite corners. And you just rub it back and forth nice and smooth. And I'll start taking a layer of that top away. Now this is 200 grit, and I brought 200 grit to try to speed up the process. I used a permanent marker to draw an X on the top of it, just so you could see the sanding away of it. But it's starting to go. And if you look on the outside, you can start to see copper.
So you want to set it all the way down to copper, then smooth it out.
That's exactly right. Now take off that complete zinc top coating.
So my question is, why do they put all that on there if it's better to not have it on there?
You will see processes that are
Speed of manufacturing.
that's end result, yes. If you look at older processors and laptop processors, desktop processors, they're just a die on top of it. They don't have any coating. It's just a die. You tap that a little too much, shot.
All the way down to the copper.
Oh yeah, then I'll take it down too.
Kind of melts that.
I just worry about flatness.
Flatness.
You never know if you're gonna get. I mean, you have the back of the belt sander,
Well, I got rough, fine, and real fine.
but can you put something behind underneath that belt?
Yeah.
'Cause that's what you want.
Instead,
Yeah, you want to put like a piece of glass or something to keep that flat.
Goldfish.
I'm gonna just say trash this thing, and I'm just